be talking with you today about a project I've been working on for the last few years in conjunction with the Lassen National Forest, Plumas National Forest, also our regional ecology program, of which Kyle Merriam, my co-author, works for, as well as a private timber company, the Collins Pine Company. And we got together to take a look at what the effects of timber harvest would be on the rare plant species Penstemon personatus. So first, a little bit about this species. Penstemon personatus is endemic to the northern Sierra Nevada. You can see its distribution in red on the Google Earth map to the right. So most occurrences are occurring between Butte Creek and the North Fork of the Feather River, with a few scattered populations elsewhere. One of these populations up north, where the yellow star is, straddles a boundary between the Collins-Almanar Forest, privately held, and also the Plumas National Forest. And this is a species that both private and federal land managers are concerned with. At the Forest Service, we manage for it because of its status as a Region 5 sensitive species. And the Collins Pine Company, they are managing for it because it has a rare plant ranking of 1B.2, and that's something that they need to address in timber harvest plans. A lot of times where this plant occurs under a shaded canopy, it will take the form that you see in the top left over there, where it's a low-growing understory form with a couple sets of opposite leaves. But where it has some light, it will send up a really tall flowering stalk, like you see on the right, with a really beautiful inflorescence of pink-purple flowers. It is rhizomatous, and so in the absence of light, frequently it is just persisting in the understory in vegetative form. So this collaboration was possible because we were all kind of grappling with the same thing. I want to tie this back to some of the presentations that we heard yesterday. Many of our rare plant species evolved in systems that experience periodic disturbance, primarily from fire. As Eric Knapp showed us so clearly last night, we really have been lacking that from the landscape over the last 120 years. We're not experiencing that. And then, as Zeke Wonder spoke with us about, we know that because we've excluded fire, when it does enter, is going to burn very differently than it may have historically. The answer to that is to reintroduce fire to the landscape, but as he explained, there's a lot of constraints to that, particularly on private lands with the liability issue. And even in federal land agencies, we simply can't keep up with the pace and scale that would be required to reintroduce fire on a meaningful level. So that leaves us to consider some other tools. And what we wanted to do in this study was to ask how disturbance from logging was similar to and or different from disturbance from fire. And this is a very generalized table up here, but I just want to bring up a few points. One thing that fire does is it removes litter and duff and can expose bare mineral soil that can help plants germinate. Logging can do that, but can also be accompanied by the deposition of slash and potential soil displacement that may be detrimental to plants. Fire can remove some overstory vegetation and have more light come down to the forest floor, but not necessarily low severity fire, whereas a lot of logging will result by selecting the bigger trees, some more light coming through to the forest floor. So in this study, we really wanted to focus on a couple of aspects of what these logging treatments would do. We wanted to look at bare soil, slash deposition, soil displacement, and then also the effects of canopy opening. Specifically, we were asking these questions. How do timber harvest activities, thinning, group selections, and we're not talking 40-acre clear cuts, we're talking about quarter to third acre openings that are put on the landscape. How do these treatments affect Penstemon personatus habitat attributes and also density of that species? Does decreased canopy cover result in increased flowering and or seed set? And then we added a pollinator component to this as well, asking whether pollinator visitation varied by habitat attributes and trying to get at what might drive these relationships, whether it was available flowers or site microclimate. To take a look at this, so this is a Google Earth image taken prior to treatment. So this is from 2016. We established 60 plots within this area that straddled Collins-Almanar Forest and Plymouth National Forest. We had control plots in green on the right, on the Plymouth, and then that represented about a quarter of our 60 plots. We had about half of our plots in mechanical thinning treatments and another quarter specifically in group selections. Collins Pine didn't really want me to have a bunch of rebar sticking up when their equipment came through, so I monumented these with giant metal washers that we buried about 6 inches underground. Following treatment, see if you can see that, see how it opened up? Following treatment, I had to go back out there with a metal detector in one hand and a GPS in the other and walk around in circles looking to refine my plots. This kind of unusual plot foraging behavior was a little bit concerning to a few passersby, and I had 3 different log truck drivers to stop and ask me if I was okay. And I think they meant like in the head okay. But it worked, and we recovered. I had kind of over-replicated, and we ended up recovering 50 plots, which was good moving forward. So those treatments, thanks to the incredible Collins Pine foresters, they did exactly what we wanted them to do. Mechanical thinning resulted in a decrease in basal area. Group selections brought it down even further. We saw an increase in bare ground cover. We saw a decrease in litter cover. And then in the top right, you can see that the percent maximum solar radiation that these meter square plots experienced during the growing season increased from 16% to 42% in the thinning treatments, and from 23% to 68% in group selections. So a lot more light became available. So normally a graph like this is really bad news because your data is scattered everywhere and there's no relationship. But in this case, I was happy to see it because what this is showing me is that the plots that experienced a change in bare ground cover weren't necessarily the same plots that experienced a change in available light. So we were going to be able to disentangle the light versus ground disturbance effects pretty well. So first, let's talk about ground disturbance. There was a decrease in density across the third of the plots that experienced soil disturbance across more than 50% of that meter square plot. They decreased by 8 stems per meter square that first year post-treatment, whereas the low disturbance plots increased. By 2 years post-treatment, those high disturbance plots have recovered to come really close to their pre-treatment densities, and this is just vegetative stems. Looking at light, we see a really strong relationship between the percent max solar radiation experienced by those plots and the number of flowers that they're producing per meter square. This is on a log scale too, so the effect was quite striking. Prior to treatment, all of the plots occurred at the left side of that x-axis, so most plots were experiencing less than 30% of their maximum available light. So we really only had flowering data representing a very small piece of this graph. So once we open it up, we can see that that relationship holds even as we've opened the canopy way up. We also were able to ask whether treatments were associated with the size of floral displays for these plants. Just as you're walking back out there, you can see in the bottom right, just note the difference between those small vegetative stems in one of the opening slides and the explosion of flowering that you see. This is from one of the group selection sites. Across the years, we had averages of about 5 flowers per flowering stem in our control plots, but that goes up to an average of 19 flowers per flowering stem in our group selections post-treatment. So I was interested too, like, okay, so we've got some losses due to soil disturbance, and we've got more flowering. How do these balance each other? So in 2018, I tagged at the beginning of the season some capsules that we're developing, harvested those in the fall, counted the number of seeds in each capsule to come up with a way to estimate the predicted number of seeds that would be produced by each plot per meter square. So as you can see, the predicted number of seeds per plot is higher in the group selections by about 2 orders of magnitude than those in the control plots. So next, pollinators. In 2018, decided to add pollinators to this, and the first thing we did was just to see who comprised this pollinator community for Penstemon personatus. And at first I thought maybe it was like 1 or 2 species, but as we started to sample visitors, we ended up coming up with about 15 different pollinator species that were there. So we made some collections, and then I brought these to this amazing group of professors emeriti at the Bovee Museum of Entomology at UC Davis. And we worked on microscopes for 12 hours. They were dusting off old bee keys to get everything identified to species. So here's some close-up imagery of some of these pollinators. A lot of them are in this plant family. It's tough to take the botanist into these. Bee family, the Megachilidae. And these species are characterized by carrying the pollen on scopy or hairs that are on the bottom of their abdomen. So a lot of the visitors to Penstemon personatus are members of this group. You can see a beautiful ash mediella off to the left, and then on the right are 2 specimens of Osmia cobaltina. The one on the left has the white pollen from Penstemon personatus held on its abdominal scopy. So we made some formal observations of pollinators in July 2018, and then mid-July and late July 2019. And for each of these sampling efforts, I had a bunch of seasonal crews off of the Lassen and from UC Davis come out and help with this. Every plot that had an available flower in it would get a 15-minute observation period. It was very zen. You just sit there and you watch, and we had identified, I learned from all of the identifications, there's no way we could identify to species, just looking at pollinators flying in on the wing, but we were able to identify broader taxonomic groups. So we took a look, noted whether the plot was in the sun or the shade, wind speed, etc., and made counts of who was visiting those plots and how many flowers they visited within that observation time frame. And what we found was pretty interesting. We wanted to know whether pollinators were drawn to the plots that had more flowers in them. And the answer was a very clear yes, and more so when those plots were in the sun at the time of sampling. And this relationship held true for just about every pollinator variable that we looked at. Plots with more flowers attracted more unique visitors, especially if it was in the sun. They received more flower visits within 15 minutes. And they attracted more unique bee taxa as well. So I took a look at the data in a little bit of a different way a few days ago to see if we could get at whether the treatments affected how different pollinator species utilize this landscape. I applied a regression tree analysis to ask which factors best predicted whether a plot was going to get a visit from 2 of our major pollinator groups, Bombus and Osmia, within our any given 15-minute observation period. And we had lots of different variables I could throw into this model: treatment, available flowers, number of flowering stems, cover, percent max solar radiation, light environment, the year that was sampled. And it was kind of interesting what we found. For Bombus, we had somewhat of a complicated model. The overall determinant of whether you were going to get a Bombus visiting there was whether you had more than 39 available flowers in that plot. If you did, a Bombus was probably going to come visit it while you were sitting there watching. If not, then you ask, well, is the plot in the shade or partial shade? Yeah, it's probably not going to get visited by Bombus. If it's in the sun, are there more than 2 available flowers? Are there other forbs present? If so, Bombus is probably going to come visit during that time. For Osmia, it was a lot less complicated. With all those variables, treatment, light, this, that, the only thing that really mattered for Osmia was how many available flowers were in that plot. The plots that had more than 26 available flowers, tended to have a visit from an osmia during that 15-minute time period. So overall, the timber harvest treatments provide a net benefit to Penstemon personatus at this site. We found overall the small decreases in density were really offset by increased flowering and larger floral displays in the areas that receive more light. We found increased pollinator activity where there was higher flower densities, and also where plants were in the sun, which happened more in some of our treatments. All right, that's all I have. Do you have any questions? This is a video.